Next, let's go ahead and enable the secrets database secrets engine inside Vault. And there we go, it's enabled. Okay, next thing I'm going to do is I'm going to configure Vault with the proper plugin and connection information. Notice I've allowed only 2 roles for this database. Next step is I'm actually going to configure those roles. So the first one here being Scorpion. So Scorpion will have these privileges to this database. So basically, you can read and insert tables into the database. And for Sub-Zero, basically only select, which is basically a read-only privilege. Once that's done, let's just double check to see if we can access the Postgres database using the credentials I showed you earlier in the YAML file. So there we have it. We've connected into Jono's DB. As a best practice, you should rotate the root credentials immediately after the initial configuration of each database. So let's go ahead and run this command. So which means if I were to run this command again, I will no longer be able to access the database using those credentials. So as you can see there, it has failed. Okay, so let's go ahead and test this out. And before I do, I'm just going to set an environment variable for my pod, for my Postgres pod. So now that that's up and running, once we declared, I should say, let's go ahead and read the credentials of Scorpion. Let's clear this. So there are the credentials, the list ID, the duration, the username and password. So when we go ahead and log into the database, we'll use these credentials. Make sure you specify the database at the end. Enter the password. And there you have it. Let's have a look at our roles. So there you go, we've got the original Postgres, and now we've also got Scorpion role, and you can see when the password is valid till. Let's go ahead and create a table, and let's add some data into this table. So let's go ahead and insert the fatality names. So that's been created. So if I were to look at table fatality, there you go, that's the data I just inputted, so chain reaction. Let's exit the database and let's log in as Sub-Zero. So let's go ahead and grab his credentials. So there you go, same thing, username, password. So we'll use the information to log into the database. So there we have it. So let's see if we can read the fatality database. So there you go. So let's test this to see if Sub-Zero himself can enter his fatality name into the database. And there you go, permission denied, because again, as you saw earlier when we were creating these roles, the privileges for the Sub-Zero role was read only. And let's just double check, the users. So there you go. We've got both Scorpion and Sub-Zero. So what I want to do now is I'll exit from here and I'll log back in as Scorpion just to double check to see if I can add more data to the table. So let's exit from here and let's log in as Scorpion again. Let's enter the password. Again, they're the two users. Let's have a look at table fatality. There we go. So let's go and see if we can insert another row to this table. Okay, so let's try this. There we go. So it's been inserted. So let's have a look at the table again. And there you go, we've got two rows. So Scorpion is able to update the database, whereas Sub-Zero does not have the right privileges to make any changes to the database besides reading the tables themselves. And to actually see the privileges, what we can do is we actually can run this command. And you can pretty much see that for this particular table, so you've got Scorpion and Sub-Zero. You can actually, if you see here are the actual privileges that Scorpion has on this table or database. And for Sub-Zero, we only have read. So there you have it. So to summarize, this video was to show how simple it is to deploy a Kubernetes cluster in GCP using Terraform Cloud. I then deploy Vault and Consul, with Consul as a storage backend for Vault on the same Kubernetes cluster. I then deployed a Postgres database and used Vault to manage roles and privileges to that database, which were users Scorpion and Sub-Zero. As a best practice, you should always use tokens with the appropriate set of policies based on your role. In this example, I used the root token, which had the root policy assigned to it. This root policy is capable of performing every operation for all paths, so it's not wise to do this in production environments. So why use dynamic secrets? Well, a dynamic secret is generated on demand, not like static secrets which are defined ahead of time, and they probably don't often get changed. Vault can be used to centralize these secrets that not only associate a secret with the lease, but it also destroys the credentials when the lease expires. It can also revoke these secrets should they get into the wrong hands, thus minimizing the life of the secret. This makes it harder for the attackers and minimizes the risks involved. Well, I hope you found the video useful, and thanks for watching.